Right now, as you watch this video, the world is facing a soil crisis that could threaten global food security within our lifetime. We've lost half of Earth's topsoil in just 150 years. Farmers spend over $200 billion every year on fertilizers that degrade the very soil they're supposed to feed. Scientists warn we may have only 60 harvests left if we continue on this path. But here's what nobody's telling you. We already solved this problem. Over 70 years ago, a British scientist perfected a method that creates endless soil fertility. Not better fertility, not improved fertility, endless fertility. Soil that gets richer and more productive with every passing year, forever. One plant, one method, infinite fertility. It worked in trials. Farmers loved it. The data was undeniable. But somehow this solution disappeared from mainstream agriculture. Today, most gardeners have never heard of it, and industrial farms have completely abandoned it in favor of methods that actively destroy soil. So what happened? Why is nobody using the only method that actually solves soil fertility permanently? And more importantly, could this forgotten technique save our dying farmland before it's too late? This is the story of endless soil fertility, the scientist who proved it works, and the forces that made sure you'd never know about it. To understand why this matters, we need to talk about what we've done to our soil. For thousands of years, human agriculture worked with a simple principle. You must give back to the soil what you take from it. Farmers knew this instinctively. Grow crops one year, plant legumes the next, rotate animals through fields, add compost and green manure, build soil, don't mine it. This wasn't just philosophy, it was survival. If you destroyed your soil's fertility, you destroyed your ability to eat. So farmers developed sophisticated systems to maintain and even improve soil fertility over generations. And it worked. For millennia, the same fields produced harvest after harvest, getting better with time, not worse. Then came the Industrial Revolution in agriculture. In the 1950s and 60s, the message from agricultural science and industry was clear and seductive. Forget the old ways. Chemistry had made them obsolete. Why waste time with crop rotations and cover crops when you could just pour synthetic fertilizer from a bag? The promise was irresistible. Triple your yields. Feed the world. Modern, scientific, progressive. Farmers who resisted were told they were backwards, stuck in the past. The future was chemical inputs, monoculture crops, and maximum production. The Green Revolution, they called it, and it did save millions from starvation. But there was a cost nobody talked about. Those synthetic fertilizers, they're salts. They kill soil biology. The bacteria, fungi, and countless microorganisms that build healthy soil structure, they die. Without that living network, soil structure collapses. Water can't infiltrate. Roots can't penetrate. Organic matter disappears. Worse, those water-soluble fertilizers don't stay where you put them. Half of what farmers apply washes away into groundwater and streams. That runoff has created over 400 ocean dead zones worldwide, areas where excess nutrients fuel algae blooms that suffocate all marine life. The Gulf of Mexico dead zone covers an area the size of New Jersey every summer, and the soil itself? It's dying. Studies show agricultural soils today have lost 50 to 70% of their organic matter compared to pre-industrial levels. That's not just bad for plants, it's catastrophic for our climate. Healthy soil is one of Earth's largest carbon sinks. Degraded soil releases that stored carbon back into the atmosphere. We created a system where farmers must apply more fertilizer each year just to maintain yields, because the soil itself is getting worse, not better. It's a chemical treadmill with no exit, and it's not sustainable. Farmers know this. Agricultural scientists know this. Anyone paying attention knows this. The question isn't whether our current soil fertility model is broken. It's whether we'll change course before it's too late. The UN has warned that at current degradation rates, global topsoil could be depleted within 60 years. 60 years. That's within the lifetime of children being born today. So why isn't anyone panicking? Why aren't we mobilizing to solve this like the crisis it is? Because most people assume we don't have alternatives. They think this is just how modern agriculture works. Chemical inputs are necessary evils. There's no other way to feed 8 billion people. But that assumption is completely wrong. Meet Lawrence D. Hills. In the 1950s, while the agricultural establishment was rushing headlong into chemical dependency, Hills went in the opposite direction. He wasn't a conventional academic. He was a journalist and organic growing advocate who founded the Henry Doubleday Research Association, dedicated to proving that organic methods could be more productive than chemical farming. And he became obsessed with one plant, comfrey, specifically a variety he perfected called Bocking 14. To Hills, this wasn't just another garden plant. It was the biological engine that could power sustainable agriculture forever, the key to endless soil fertility. And he spent 40 years of his life proving it. Here's what Hills discovered. Most plants are trapped at the surface. Vegetable crops, grains, even most perennials send roots down maybe 2 feet, 3 at most. That's their entire feeding zone. But below that, there's a treasure trove of nutrients. Every time it rains, minerals wash down from the topsoil and accumulate in the subsoil, 3, 4, 6 feet deep or more. Nitrogen, phosphorus, potassium, calcium, magnesium, everything plants need just sitting there, locked away where shallow roots can't reach it. It's like having a bank vault full of gold beneath your feet, but no key to open it, unless you're comfrey. Comfrey's taproot drives 6 to 10 feet into the subsoil. It's not browsing the surface like other plants. It's mining. Those powerful roots break through compacted clay, penetrate hardpan, and extract minerals that have been accumulating for decades. Then, and this is the genius part, comfrey pumps those deep nutrients up into its leaves. The plant becomes a biological elevator, moving fertility from deep in the subsoil up to the surface, where your crops can actually use it. Hills didn't just make claims, he measured everything. Over 40 years of trials, he documented that comfrey leaves contain 5 to 7% potassium on a dry weight basis. For context, animal manure, which farmers have used for thousands of years, contains about 0.5% potassium. Comfrey has 14 times more. Plus substantial nitrogen for vegetative growth, phosphorus for roots and flowers, and a complete spectrum of trace minerals. But what really sets comfrey apart is how quickly those nutrients become available. Most organic materials take months to break down. Comfrey leaves? They start decomposing within days. Within 2 weeks, they're black gold, rich, crumbly, nutrient-dense material that plants can absorb immediately. Hills ran side-by-side trials comparing comfrey to synthetic fertilizers, animal manures, and other organic amendments. The results were consistent. Comfrey-fed plants matched or exceeded the growth and yields of chemically fertilized plants, while simultaneously building soil structure, supporting beneficial microbes, and requiring zero external inputs. By the 1970s and 80s, Hills had built a movement. The Henry Doubleday Research Association grew to thousands of members. Organic gardeners and small farmers across Britain were establishing comfrey patches and documenting incredible results. His books became classics in organic growing circles. International interest grew. People from Australia, New Zealand, North America, and Europe wanted Bocking 14 root cuttings. This wasn't fringe experimentation. This was a legitimate, data-backed, proven method for creating sustainable, improving soil fertility. A biological system that got better with time instead of degrading. The exact solution agriculture desperately needed. So why didn't it catch on? Why did the agricultural mainstream ignore and eventually forget about Hills's work? The answer reveals everything wrong with how we think about farming and progress. Let's start with the uncomfortable truth. Comfrey's greatest strength is also its greatest weakness in a market economy. It's free. Plant it once, and it produces for 20-plus years with zero inputs. No one can patent it. No company can control its distribution. There's no recurring revenue stream. Compare that to synthetic fertilizer. Farmers must buy it every single year. The fertilizer industry generates over $200 billion annually in sales. It's a subscription model. Farmers are locked into purchasing inputs season after season, year after year. From a business perspective, synthetic fertilizer is the perfect product. From a sustainability perspective, it's a disaster. But guess which model gets billions in investment, marketing, and institutional support? Guess which one funds agricultural research at universities? Guess which one gets promoted by extension services and taught in farming programs? Comfrey doesn't have a marketing budget. It doesn't have lobbyists. It can't buy influence or fund studies. It just grows, quietly producing endless fertility for anyone willing to plant it. Then there's the scale problem. Modern agriculture has optimized for size and mechanization. Farms have gotten bigger, labor has gotten scarcer, and everything is designed around doing one task across massive acreage as quickly as possible. You can fertilize 1,000 acres with one truck and one person in a day. Comfrey doesn't work that way. It requires some hands-on management, cutting leaves, distributing them, repeating monthly. At garden scale or small farm scale, this is perfectly manageable. 5 minutes of work once a month. But at industrial scale, it doesn't fit the model. So industrial agriculture looked at Comfrey and said, "This doesn't work for us," and moved on. Never mind that it might work brilliantly for the millions of small farmers worldwide, or for home gardeners, or for any operation where building soil matters more than short-term convenience. It didn't fit the dominant paradigm, so it was dismissed. Perhaps most tragically, we lost the knowledge itself. As older farmers who practiced traditional soil-building methods retired or passed away, their techniques went with them. Agricultural education shifted entirely toward industrial methods. By the 1980s and 90s, entire generations of farmers were trained exclusively in chemical input agriculture. Comfrey wasn't even mentioned in most farming programs. Young people entering agriculture learned one system: synthetic fertilizers, pesticides, herbicides, genetically modified seeds designed to work with those chemicals. That's what modern farming meant. The old ways were written off as backwards, inefficient, unscientific. Hills kept advocating until his death in 1991, but he must have felt like he was shouting into a void. The agricultural establishment had made its choice, and there was no going back. There was one more nail in the coffin. In the 1980s, studies identified pyrrolizidine alkaloids in comfrey, compounds that could cause liver damage if consumed in large quantities over extended periods. This became a legitimate concern for comfrey's use as herbal medicine or animal fodder. But here's what got lost in the panic. Using comfrey as garden mulch or fertilizer involves zero internal consumption. The health risks simply don't apply. You're not eating it. You're not feeding it to livestock long-term. You're laying leaves on soil where they decompose. But nuance doesn't survive controversy. People heard comfrey toxic and abandoned it entirely, even for uses that were perfectly safe and had been practiced for centuries. What should have been a specific warning about internal consumption became a general fear that killed off even the legitimate agricultural applications. It was the perfect storm. Economic interests aligned against it, scale didn't fit industrial agriculture, knowledge transmission broke down, and public perception turned negative. Comfrey went from cutting-edge soil science to forgotten relic in just one generation. But here's the hopeful part of this story. Comfrey is coming back, quietly, without institutional support or corporate marketing. A new generation of farmers and gardeners is rediscovering what Lawrence Hills proved 70 years ago. The regenerative agriculture movement, the permaculture community, no-till farmers, climate-conscious gardeners, they're all asking the same questions. How do we build soil instead of depleting it? How do we create fertility without fossil fuels? How do we farm in ways that sequester carbon instead of releasing it? And when they go looking for answers, they keep finding comfrey. Social media has accelerated this rediscovery. YouTube gardeners show their comfrey patches and massive harvests. Instagram permaculture accounts share before and after soil photos. TikTok videos explain the nitrogen-fixing partnership. Information that was almost lost is suddenly spreading virally. Modern soil science is also catching up to Hills's observations. With tools he never had access to, DNA sequencing, advanced microscopy, soil carbon analyzers, researchers are documenting exactly how and why comfrey-based systems work so well. They're measuring the microbial communities these systems support, the soil carbon they sequester, the nutrient cycling they enable. And they're finding that Hills was right about all of it. Comfrey doesn't just add NPK, it builds complex soil food webs that create resilient, self-maintaining fertility. Those deep roots don't just mine minerals, they create pathways that improve water infiltration and soil aeration for years afterward. The rapid decomposition doesn't just release nutrients, it feeds an explosion of beneficial bacteria and fungi that suppress diseases and help plants thrive. This is what sustainable soil fertility actually looks like. Not a product you buy every year, but a living system you cultivate once and benefit from forever. The testimonials are pouring in. Home gardeners who planted comfrey 5 years ago and haven't bought fertilizer since. Small farmers who've cut their input costs to zero while increasing yields. Market gardeners producing premium vegetables in soil that gets better every season instead of worse. These aren't corporate case studies or funded research trials. These are regular people who took a chance on a forgotten method and discovered it actually works better than what replaced it. They're building the kind of soil that can feed families for generations, not just for one season. And they're sharing what they learn, creating a knowledge network that's bypassing the traditional agricultural establishment entirely. The biological engine of soil fertility is starting to hum again. So here we are. We have a soil crisis that threatens global food security. We have a method that solves it permanently, that we've known about for 70 years, that's been proven to work countless times. And we have a choice. We can keep doing what we're doing, pouring chemicals on dying soil, spending billions annually on a system that makes the problem worse, racing toward the depletion of our topsoil. Or we can remember what Lawrence Hills tried to teach us, that endless soil fertility is possible, that nature has already solved this problem, and that the solution is still available to anyone willing to use it. This won't come from the top down. The fertilizer industry isn't going to promote solutions that eliminate their market. Industrial agriculture won't voluntarily change the model it's built on. Agricultural policy won't shift until we force it to. But it can come from the bottom up. Every gardener who plants comfrey, every small farmer who establishes fertility patches, every community garden that shares root cuttings, every person who builds living soil instead of buying dead chemicals. That's how we get there, one patch at a time, one garden at a time, one conversation at a time. The method that generates endless soil fertility hasn't disappeared. It's been waiting for us to remember, waiting for us to choose a different path, waiting for us to realize that the solutions we need don't require new technology or massive funding or institutional permission. They require us to listen to what the earth has been trying to teach us all along. Lawrence Hills died in 1991, but his work didn't die with him. The comfrey plants he bred are still producing. The data he gathered is still valid. The method he perfected still works exactly as he said it would. The endless fertility he proved possible is still endless. The only question is whether we'll use it, whether we'll choose regeneration over degradation, whether we'll build soil or keep destroying it, whether we'll work with nature or keep fighting against it. One method generates endless soil fertility. Now you know about it. Now you know why almost nobody uses it, and now you get to decide whether that changes. The biological engine is ready. The solution is here. The soil is waiting. What happens next is up to us.